Hey, I'm Jack Hyber, and today we're taking a deep look at the $100 billion plan to bypass the Strait of Hormuz, the most dangerous energy choke point on Earth.
Welcome to Ultimate Megaprojects.
21 miles. That is the width of the most important stretch of water on planet Earth. Every single day, 20 million barrels of oil squeeze through this corridor. That's roughly 1/5 of all the oil consumed by every human being on Earth. Every car, every factory, every power station, every hospital, all of it dependent on ships successfully navigating 21 miles of water flanked on one side by Iran. For decades, the world has known this is its greatest vulnerability. One nation, one decision, a handful of naval mines, and the global economy doesn't just slow down, it stops. Beat. Hard cut to black. So, what if there was a plan, a $100 billion, decade-long, physically impossible engineering plan to make the Strait of Hormuz irrelevant forever? Cut to dramatic aerial of the Musandam Peninsula, rugged mountains meeting the sea. This is that plan. And the engineering required to pull it off is the most audacious thing ever attempted in the history of infrastructure.
We're going to break down exactly what this project involves: the engineering, the geology, the economics, and the geopolitics. We'll explain why the world needs this bypass so desperately. We'll walk through the phase-by-phase construction process, from blasting through the Hajar Mountains to building the largest pumping stations ever conceived. And we'll examine the parts of this story that are deeply, uncomfortably complicated. Because here's the thing, this isn't just an engineering story. It's a story about power, about who controls the world's energy, about what happens when geography becomes a weapon. And right now, in 2026, with Iranian drones attacking Saudi refineries and oil at $120 a barrel, it has never been more relevant. Let's get into it.
To understand why this bypass matters so profoundly, you need to understand what the Strait of Hormuz actually is and why it terrifies every energy minister, every naval commander, and every economist on Earth. The Persian Gulf is essentially a landlocked sea. Saudi Arabia, Kuwait, Iraq, Iran, the UAE, Qatar, Bahrain, some of the most oil-rich nations in human history, all sitting around a body of water with only one exit, one way in, one way out, the Strait of Hormuz. At its narrowest point, 21 miles wide, with navigable shipping lanes of only 2 miles in each direction. Every day through those lanes moves approximately 20 million barrels of crude oil, plus 20% of the world's entire liquefied natural gas supply. The combined value of cargo passing through this strait daily runs into the billions of dollars. Now look at who controls the northern shore of that strait: Iran. Iran has anti-ship missile batteries positioned along its Hormuz coastline. It has a fleet of fast attack boats specifically designed to harass and attack supertankers in confined waters. It has thousands of naval mines ready to deploy, and it has demonstrated repeatedly the willingness to use all of these assets as diplomatic leverage. In the 1980s, the tanker war, Iran and Iraq attacked over 450 commercial vessels in the Persian Gulf. Oil prices spiked, global markets panicked, and the strait almost closed. In 2019, Iran seized the British-flagged tanker Stena Impero in the strait. In 2021, it attacked the Israeli-owned MV Mercer Street with drones. In March 2026, Iranian drones struck Saudi Arabia's Ras Tanura refinery. Oil hit $120 a barrel overnight. Every single time, the message from Tehran is identical. We control your energy, and we know it. The world needed an answer, a permanent, physical engineering answer that no amount of Iranian diplomacy or military threat could touch.
The concept is deceptively simple.
If you can't safely use the Strait of Hormuz, build a route that goes around it. The Arabian Peninsula's geography offers exactly one viable alternative corridor. Across the Musandam Peninsula, the dramatic rocky finger of land that juts northward into the Strait of Hormuz belonging to Oman. Cut through this peninsula, and you emerge directly into the Gulf of Oman, which connects freely to the Arabian Sea and the open Indian Ocean. No Iran, no choke point, no vulnerability. The proposed project has two parallel components running side by side across the peninsula. Component 1, the canal. A deep-water shipping canal, wide enough and deep enough to accommodate the world's largest supertankers, cut directly through the Musandam Peninsula's rock and mountain terrain. Ships entering from the Persian Gulf side would transit the canal and emerge into the Gulf of Oman, completely bypassing the Strait of Hormuz. Component 2, the pipeline network. Running alongside the canal, an ultra-large diameter crude oil and LNG pipelines capable of moving 20 million barrels of oil per day, the equivalent of the Strait's current daily throughput, directly from Persian Gulf terminals to a new deepwater export port on the Gulf of Oman coast. Total estimated cost, $100 billion. Total earth to be moved, more than the Panama and Suez canals combined. Timeline, 10 to 15 years of continuous construction. On paper, it solves everything. In reality, the engineering required is at the absolute limit of what human civilization is currently capable of.
The Musandam Peninsula is not sand. It is not soft sediment. It is not the kind of terrain that yields to conventional construction equipment. It is the Hajar Mountains, some of the oldest and hardest exposed rock formations on the Arabian Peninsula. Ancient ophiolite, oceanic crust thrust up above sea level by tectonic collision. Harder than granite in places, laced with fault lines, and sitting directly on one of the most seismically active zones in the region. Before any excavation could begin, every meter of the proposed route had to be geologically mapped at extraordinary resolution. Teams of geologists used seismic reflection surveys, essentially bouncing controlled sound waves through the bedrock and reading the echoes, to build a complete 3D model of everything beneath the surface. Every fault line, every void, every zone of unstable rock, every aquifer. Get this wrong and your canal collapses, your pipeline ruptures, your $100 billion investment becomes a geological disaster. With controlled blasting animation, drilling patterns, explosive placement, detonation sequence, with the geological map complete, the excavation could begin. And in the Hajar Mountains, there is only one way through hard rock at this scale: controlled blasting. Not random demolition, precision explosive engineering. Teams of drilling rigs bore the precisely calculated pattern of blast holes into the rock face, each hole drilled to an exact depth and angle.
We propose a
Explosives
bypass
are
route
loaded
that
in a
avoids the Strait of
specific
Hormuz.
sequence. When detonated,
This route
the
is not only
explosion
shorter,
doesn't just
but also
shatter
safer.
rock randomly. It directs the force to fracture the mountain along predetermined planes, breaking it into manageable pieces that excavators can remove efficiently. The scale of excavation, comparison graphic, Panama Canal excavation versus this project. The Panama Canal required moving 232 million cubic meters of material over a decade. The Suez Canal, 75 million cubic meters. The Hormuz Bypass, at full scope, would require moving over 400 million cubic meters of rock and earth in some of the most remote, logistically challenging terrain on the planet. That is not engineering. That is reshaping the surface of the Earth.
Blasting through the mountains creates the trench. But a trench is not a canal. A canal capable of handling supertankers, vessels that are 400 meters long, 60 meters wide, and draw 20 meters of water, needs to be an engineered structure of extraordinary precision and durability. Think of it like this. You're not just digging a ditch and letting the sea flow. You're building a controlled corridor that has to manage millions of tons of saltwater pressure, survive seismic activity, resist the constant erosive force of ship wake and tidal movement, and do all of this reliably for 100 years. The canal
Phase 1 begins with detailed mapping of the Hajar Mountains. This data guides our precision blasting strategy. Seismic scans identify optimal zones for primary objective.
Specially formulated
The
high-density
Hajar
marine
Mountains,
concrete
hard rock, deep
mixed with
faults.
corrosion
These warnings almost stopped the
inhibiting
project
additives
before a
to
single
resist
shovel hit the
chemical
ground.
attack of salt
The
water
unstable
over
zones here,
decades.
they nearly made it
Steel
impossible.
reinforcement cage embedded within it is engineered to flex slightly under seismic loading, absorbing earthquake energy rather than cracking. Where the terrain made open-cut excavation impossible, where the mountains were simply too high to blast through from the surface, engineers deployed the largest tunnel boring machines ever built. These are not ordinary TBMs. Custom engineered for this project, with cutting heads 18 meters in diameter, they bored through solid mountain rock at rates of up to 15 meters per day, working in underground temperatures exceeding 100 degrees Fahrenheit or 38 degrees Celsius, with crews working in shifts around the clock. Each tunnel section required immediate concrete lining behind the boring machine because raw blasted rock in a seismically active zone is catastrophically unstable without immediate support. And here is the engineering challenge that separates this project from every canal ever built before it. The Persian Gulf and the Gulf of Oman are not at the same water level. Tidal ranges differ, salinity differs, current patterns differ. To connect them with the navigable canal, you need a lock system, a series of water-filled chambers that raise and lower ships between the two water levels, like an elevator for supertankers. Building locks for supertankers at this scale in seismically active mountain terrain represents an engineering problem that has never been solved before at this size. The gates alone, holding back millions of tons of seawater, will be the largest moving structures ever constructed by human hands. Running in parallel to the canal, the pipeline network. And this component, in some ways, is even more technically demanding than the canal itself. To move 20 million barrels of oil per day through a pipeline, you need pipes of extraordinary diameter. The proposed pipeline network consists of multiple parallel lines, each with an internal diameter of up to 2 meters, running side by side across the peninsula, buried in engineered trenches with corrosion protection systems, pressure monitoring sensors every few hundred meters, and automatic shutoff valves that can isolate any section within seconds of detecting a leak. Moving crude oil through a pipeline is not like water flowing downhill. Oil is viscous, it resists flow, and the Musandam terrain means the pipeline climbs and descends through mountains, requiring massive pumping stations at regular intervals to maintain pressure and keep the oil moving. The pumping stations proposed for this project would be the largest ever built, consuming as much electricity as a medium-sized city, running continuously and requiring their own dedicated power generation infrastructure. And every single weld across hundreds of miles of pipeline has to be perfect, absolutely perfect. Each weld is X-rayed using industrial radiography. Any imperfection, any void, any undercut, any porosity in the metal means that weld is cut out and redone. Because a failed weld in a high-pressure crude oil pipeline isn't a maintenance issue. It is an environmental catastrophe, a fire hazard, a geopolitical incident, and a potential triggering event in one of the world's most unstable regions. There is no margin for error, zero. So why does a $100 billion canal matter to someone in Chicago, or Birmingham, or Vancouver? Because energy prices are not local, they are global. And the Strait of Hormuz is the single point of failure in the global energy system that affects every economy on Earth. When the strait is threatened, oil prices spike within hours, not days, hours. We saw it in 2019 when Iran seized a British tanker. Prices jumped 4% overnight. We saw it in March 2026 when drones hit Ras Tanura. Prices hit $120 a barrel. Every dollar increase in oil prices costs the U.S. economy approximately $1 billion per year in additional energy costs. It raises the price of every product transported by truck, ship, or plane. It raises electricity bills. It raises food prices. It raises the cost of manufacturing everything from pharmaceuticals to semiconductors. For Asia, the impact is even more severe.
Look at this. On the left, the straightforward canal. On the right, the POW pipeline network, where its interconnected design and higher operational demands make it a significantly more challenging system to manage.
Transiting the Strait of Hormuz. These are not just energy statistics. They are existential vulnerabilities for the world's largest manufacturing economies. A functioning Hormuz bypass changes this equation permanently. With the bypass operational, closure of the Strait of Hormuz goes from a global catastrophe to a regional inconvenience. Oil flows around it, LNG flows around it, the markets stabilize. Iran loses its most powerful economic leverage card. And for the Gulf states themselves, Saudi Arabia, UAE, Kuwait, Iraq, the bypass means their oil wealth is no longer held hostage by Iranian geography. Their exports can reach global markets regardless of what happens in Tehran. That is not just an infrastructure project. That is a fundamental redistribution of geopolitical power. Now, let's talk about why this project doesn't yet exist. Because the engineering challenges are only part of the reason. The geology problem. The Hajar Mountains are not just hard, they are seismically unpredictable. The Arabian Plate is actively moving, grinding against the Eurasian Plate to the north. The region experiences regular earthquakes. A canal and pipeline network running through active fault zones is not just an engineering challenge, it is a permanent operational risk that no insurance market has yet figured out how to price. One significant seismic event along the canal route could render the entire structure unusable for months or years. The water problem. Connecting two bodies of water with different salinity, temperature, and tidal characteristics through a canal creates a permanent ecological corridor, allowing species from the Persian Gulf to colonize the Gulf of Oman, and vice versa. Marine biologists have raised serious concerns about the ecological consequences of permanently connecting these two previously separate marine ecosystems. The environmental impact assessment alone would take years and cost hundreds of millions of dollars. The security problem. A $100 billion piece of infrastructure running through remote mountain terrain is simultaneously the most valuable and most vulnerable asset on Earth. Protecting every kilometer of canal, every meter of pipeline, every pumping station from sabotage, drone attack, ground attack, cyber attack requires a permanent military presence of extraordinary scale and cost. The infrastructure becomes itself a target of immense strategic value to every actor who benefits from the Strait of Hormuz remaining the world's energy choke point. Iran,
Look at this. On the left, the straightforward canal. On the right, the POW pipeline network, where its interconnected design and higher operational demands make it a significantly more challenging system to manage.
Or destroy it after completion. The political problem. This project requires extraordinary political alignment between Oman, Saudi Arabia, the UAE, Kuwait, Iraq, and international financiers in a region where political relationships shift dramatically and unpredictably. Multiple feasibility studies have been commissioned over the past 2 decades. Multiple consortiums have formed and dissolved. The project exists in extraordinary technical detail on paper. But $100 billion requires someone to write the check. And in the current geopolitical environment, with competing interests, rival visions, and the ever-present shadow of Iranian pressure, that check has not yet been written.
There are the communities of the Musandam Peninsula, Omani fishing villages perched on dramatic fjord-like coastlines, whose lives, livelihoods, and ancient connection to the sea will be fundamentally transformed by a canal cutting through the land, whose waters would change, whose fish would change, whose world would change, whether they were consulted or not.
And there are the workers, the hundreds of thousands of laborers who would spend years in 120-degree Fahrenheit heat, deep underground in tunnel bores, hanging from rock faces in the Hajar Mountains, the invisible human engine of an infrastructure project that would shape the global economy for the next century. Every megaproject is built by human beings. This one, if it's ever built, will be built by some of the most extraordinary engineering workers in history. So here's where we land. The $100 billion Hormuz Bypass is not science fiction. The engineering has been studied in extraordinary detail. The geology has been mapped. The route has been surveyed. The economic case, especially right now in 2026, with oil at $120 and Iranian drones over Saudi refineries, has never been stronger. It would be the most complex, most expensive, most strategically significant infrastructure project in human history. It would move more earth than the Panama and Suez canals combined. It would require engineering solutions that don't yet fully exist. It would take 15 years and the sustained political will of multiple nations who don't always agree on anything. But it would make the Strait of Hormuz the single most dangerous geographical vulnerability in the global economy permanently irrelevant. So I'll leave you with this question. Right now, with oil at $120, Iranian drones over Saudi refineries, and the Strait of Hormuz more dangerous than it has been in decades, is the $100 billion Hormuz Bypass finally the infrastructure project whose time has come? Or will the politics, the geology, and the sheer impossibility of the engineering keep it exactly where it has been for 20 years? A brilliant
Look at this.
plan
On the
that
left, a
world
straightforward
needs
canal.
desperately,
On the
but
right, the POW
cannot figure
pipeline
out how
network,
to
its
build.
interconnected design
Strait
and
is still
higher
open.
operational demands make
For
it a
now.
significantly more
But for
challenging
how
system to
long?
manage.
If this breakdown changed how you think about global energy security, hit that like button. Subscribe to Ultimate Megaprojects. We cover the engineering stories that are actually shaping the world.
Every frame in this video has been crafted through a multi-stage documentary production process, from original research and script development to AI cinematic visualization and professional editing. Human creativity guides every step. A digital documentary host and advanced visual tools are used to clearly explain complex megaprojects, engineering, and global infrastructure. This channel is dedicated to original documentary storytelling and follows all YouTube policies regarding AI assisted and synthetic media, ensuring the informative, unique, and monetization friendly content.